Hello everyone, my name is Anish Kumar and welcome back to probably the last video in my channel. So, today's topic is phishing detection via certificate analysis. This is the topic that I'll be presenting. This is related to digital certificates and the part where it plays a huge role in the network security. So, the topics that I'll be um, going through. Firstly, I'll start with the introduction, then the literature survey, which I'll just run through, then the methodology, then we'll check out the working and implementation, then the applications, then the advantages, disadvantages, and the future enhancements, and the conclusion or the references. At the end, the references. So digital certificates, what are they? So these are the certificates that verify whether the website or organization is the authentic one. Like for example, a certain person, he takes the ownership of the domain Amazon and he starts this website called Amazon.com even before Amazon.com could have brought that domain. So what does this do? Does it mean that the Amazon.com is actually owned by Amazon? No, it's not, because in that scenario another person is using the domain name Amazon, and people might get confused, thinking that this is probably the original Amazon.com, and they might just go to that website. But what if that person's actually an attacker or an hacker? He might like just make settings like these as that if someone enters that website, all their data will be stored in the hacker's server or wherever he wants it to be stored at. So it might be really dangerous considering today's importance of data. So that's why that is what a digital security, a digital certificate, that is exactly what it does. It authenticates a certain website or an organization. So it is issued by the certificate authorities to secure communication. The challenge includes attackers use HTTPS, making the padlock icon unreliable. So initially, what we used to think, like consider 10 years, 10 years ago, like if we saw a padlock icon on a certain website, we, uh, as in a normal people, thought, oh, there's a padlock icon there, then this website is obviously safe. We can browse, we can do whatever we want, we can enter the data, and the data will be safe, and it won't be misused. That was our thinking back then. But what if I tell you, in today's date, even if you see a padlock icon, that website might not be safe. That is what the attackers have done. Attackers are always looking for vulnerabilities. They're always looking for new methods by which they can lure people, and then they can, get uh, people to get scammed. Yeah. So, yeah. Sorry for that. Yeah. So, as you can see, this is the padlock icon. So, initially, what we used to think that if the connection is secure here, that it's peace. The person can be completely tension free, but not anymore. Definitely not. Yeah. Okay. Even the FBI or the FTC, I don't know what FTC is. FBI, from a very popular meme like FBI open up. Yeah, you all must have seen that for sure. Yeah. So FBI advise verifying beyond HTTPS. So if you see that a certain website is HTTPS labeled, you still have to be sure. You have to take those extra steps as a safe person. The person who wants to be safe. You have to take those extra steps. So next up, what is phishing? Cyber attack that tricks users into sharing sensitive information. Fake websites mimic legitimate ones like PayPal.com versus PayPA1.com. As you can see, the domain name, it looks very similar. So if a person, if he's in a hurry and if he wants to actually go to this website, might not end up in this website. He might end up in an other fake website, which might be a malicious one, and his data might get stolen in that case. And the question might arrive. This is a question that was asked to me, and that was actually a very good question. Like, if I search for PayPal, the first thing that comes, the first recommendation that comes, it should be the legit one or the authenticate one, right? The authentic one, right? But let me tell you, in today's world, the attackers have found out the I don't know what it's called. Like, it's a vulnerability or the loophole. How do you make a dummy website or a fake website to get on top of the recommendation list? What do? They use bots in this situation. They use bots, and they increase the traffic of that certain website. So what the browser normally thinks is, um, if a certain website has more traffic than original one, for example, paypa1.com has higher traffic than paypal.com, the browser obviously think that people prefer going to this website instead of this website, right? So that is when this website gets recommended at the first place, and that is how people might get scammed. So accounts for the highest number of cybercrimes. Yeah, it does. 80% of phishing sites use valid certificates. People might think if the certificates are valid, if they're like safe, then it obviously must be safe, right? But definitely not. It's not in today's world, generally not. So user reported detection. So this is what we can do. Like after we detect that a certain website is fake, a user can report that certain website, and the website or the domain will get stored in fish tank. Machine learning automates phishing detection, analyzing certificates and domains. We take use of machine learning and its principles to deal with this. So the simple thing again, we make a machine learning model, and what do? We train that model. We give them the legitimate websites. We give them the malicious websites, and then we give a few sample websites, and then we test it. And we use a classifier. Like in my situation, I've used a random forest classifier, which is known to be very accurate. So that is why I've used it. Yeah, and the difference between HTTP and HTTPS is that S, as you all know, is considered to be secured in this case. And why is it secured? What differentiates HTTP and HTTPS? Well, it's nothing but the SSL certificates that are involved with HTTPS. HTTP websites don't generally have SSL certificates, it's just HTTPS websites. And this is the literature survey. You all can pause and you all can go through this, and I'll be happy to assist you guys if you need any help with that. So methodology, the first thing that we do is the data collection. Then like we take the Benin domains from Tranco. Benin are the legitimate websites or domains, and phishing domains which are rated from fish tank, as uh, you can see here. User reported detection, example fish tank. So whenever a user reports a website, it gets stored in fish tank, and that is how we retrieve the phishing domains from there. And then certificates gathered by census. So in this situation, we take the certificates. So we test if a certain certificate is valid or not, right? So data pre-processing, remove the duplicates based on subject common names. Yeah, the duplicates should be removed. Uh, and then the label certificates as phishing or Benin based on domain match. Yeah, the labeling should be done if it's a legitimate website or a malicious website. So the final data set consists of 12,016 certificates, which are evenly split. That means 6,008 legitimate domains and 6,008 malicious domains. So feature engineering, certificate-based features like the issuer name, validity period, subject common name, and then the domain-based features like the length, entropy, suspicious keywords, subject alternative name, features aggregated domain analysis, NLP-based features. Bill STM means bidirectional long short-term memory. This is the methodology that we'll be using mainly. So we used Bill STM model to convert domain names into vector embeddings, extracted deep features from the second last layer for classification input, and finally it's a classification where we trained the random forest classifier on the combined feature set, evaluated model using the F1 score and the time-based robustness testing. Then, as I told you, source of data, banning the phishing ones, the certificates, and the data period should be between 2023 to 24. And yeah, the same thing again. So yeah, the same thing again, like whatever I had told you. It's just in more detail. You guys can like pause it. You will surely understand it in a better way. So suspicious keywords that I told about earlier. So no website will have terms like login, secure, safe. Have you ever seen a website that goes by the name like, for example, safepaytm.com or safeamazon.com, safeairtel.com? It's not the case. But the malicious websites, they try to fool people because a few people, I mean, I don't know what kind of people they are, but they might see this domain name as safe Airtel, and they might feel, oh, this is the Airtel one, but probably it's the safer version of Airtel, and they might get attacked in that scenario. Yeah. So yeah, this is the implementation. So firstly, we take the label domains, which isn't it zooming. Just a second. Yeah. So the label domains and the certificates, like we take those, and then here we just take the label domains. I'll just tell. We extract the features, like the feature extraction is done, and then the certificate features and the lexical features, like this is the feature of the certificate and this is the feature of the domain. So we take all those under consideration, and then we add this in the feature vector. And also initially we had taken the label domains, right? So the domain based feature model, like we train the model, we evaluate the model, and then we test it out with a few domain names, model that returns a vector. So what generally happens is, like if you give a model paypal.com and paypa1.com, at times the model also might get confused. So to avoid this confusion, what we do is we convert these keywords into vectors, right? A vector representation of the original keywords. So this way, even a small variation, like if I use A instead of B, even if it's a single letter that's the difference between the two words, even then we might actually get two completely different vector representations, and then we add it to the feature vector, and then we add it to the pre-processed certificates, and then we train and evaluate it based on the feature vector here, and then we see if that website is legitimate or malicious. So we put it in the classifier, and then we label it if it's a uh, you know malicious website or a legitimate website. So hope you all understood it. Oh my god, what is it? Yeah. So applications, where and all can we use it? Like cybersecurity in enterprises, like obviously data where data is very huge in number, where it's very important to keep it confidential. This will play a very important role. Then the financial institutions like online banking will surely require this. Then the email service providers to detect the fake emails, or at times people tend to add these malicious links or these phishing links in the email, and if the users click on it, they're done. So web browsers and extensions, so yeah, even in this it can be used. Then e-commerce platforms, obviously, and then cloud service providers, government and public sector, internet service providers. So the advantages and disadvantages, you all can read it, I guess. It really doesn't have too many disadvantages. It's also really good. So why did I use random classifier? I mean the random forest classifier, because it has a very high F1 score of 0.89, right? And that is what we would want. So future enhancement, what can be done is we can expand the data collection. Instead of 12,016, we can probably use like 20,000, 50,000 to give a more accurate result. And multilingual adjustments, not just English, no matter what language the domain name is in, the model should still be able to label it if it's a malicious one or a legitimate one. So the conclusion, phishing attacks have evolved with the use of HTTPS and legitimate SSL data certificates, making traditional detection methods less effective. This research introduces a machine learning based approach that combines digital certificate features with domain based characteristics, including built-in features to detect phishing websites more accurately. The model provides a balanced and proactive phishing detection system, reducing reliance on manual user reports or outdated blacklists. So these are the references. So thank you. It was a great journey, and I hope you all enjoyed this video. This was my last video, and hope you all like this video. See you again. Good night.